Hi guys, we're here for another day of 5th grade math. Earlier this week, you watched a YouTube video lesson on comparing place value, and it looked specifically at 10 times more or less and 1/10 more or less. And so today I'm going to be doing a continuation of that, just breaking down some problems with you, looking at both whole numbers as well as decimal numbers. And we're going to be looking at the difference between the place values in regards to how much they are worth. All right. So one thing you need to keep in mind throughout this entire conversation, all right, is the power of 10. All right, you really need to keep that in mind. That's actually where we're going next week. And this is the building blocks to be able to understand exponents, negative exponents, and being able to understand the power of 10. So this is the beginning of that discussion. So the first thing I want you to do is write this number on your papers. 878. All right, so here we are going to compare the 8 in the hundreds place and the 8 in the ones place. So I have 8 hundreds and I have 8 ones. All right, you should be with me so far. All right, so right here, 8 is not written, 800s is actually not written in number form here. It's a combination of number and word form because we're referencing its place value. But in order to understand comparing place value, what we need to do is actually convert that over into number form. So our 800s, how would I get that in number form? I would take 8, multiply it by 100 because that is my place in the place value. And 8 times 100, well, we know that 8 times 1, that's 8. And then I have 2 zeros left over, so I'm going to attach those 2 zeros right there. All right, that right there is you using the power of 10 to multiply. All right, we've talked about that. You've been hearing about it in math since 3rd grade, that when you multiply any number by 1, you get the same number. But what happens when we multiply that number by a 1 with a 0 on the end, or a 1 with 2 0 on the ends, therefore being 10 and 100 respectively? What happens then? Well, it's the same concept. We are still getting the same number, but now we have these bags on the end, these 0 bags, and we have to attach those to the end. Same number of 0 bags I start with should be the same number of 0 bags that I end with. Okay? So keep it in mind like that. Think of it like that. That's baggage. That's luggage on the end that goes everywhere that goes. That number 1 goes. Okay? Sometimes the 1 has no baggage, which is number 1. Sometimes it only has 1 bag, which is a 10, and so forth. So hopefully that helps in your thinking of the power of 10. So now I have these 8 ones. So I'm going to go 8 times 1. We just talked about this guy's got no baggage. So 8 times 1 we know is 8. All right. So how do I get from here to here? That's the question of the hour, right? How do I get from there to there? Well, let's look at it. They both have an 8 in them. But this guy has 2 zeros more. Well, if we're talking about the number 1 and all of its baggage, what do we call a 1 with 2 0 bags on the end of it? If you said 100, then you are correct. To get from 8 to 100, we already see we multiply by 100. So that means that this is 100 times more than that. And on the reverse of that, this is 1/100th less. All right, remember, division and multiplication, they are partners in the mathematical game of life. All right. So the opposite of multiplication, the inverse of that is division. So if 800 is 100 times more, then 8 would be 1/100th less of 800. All right. So that is what you are looking at. So when you get a problem and it says, for example, the 8, how does the 8 in the ones place compare to the 8 to its left? All right. Well, you would say the 8 in the ones place is 1/100th less than the 8 to its left. You could do the reverse of it. How does the 8 in the hundreds place compare to the 8 in the ones place? Well, or you would actually say the 8 to the right of it. The 8 in the hundreds place is 100 times more the 8 to the right of it. All right. So we're going to move on to another problem. But there's something else. Remember I said I want you to remember that power of 10? There's something else you're going to need to remember. When you're looking at problems like this and you're comparing the place value, one thing that you have to keep in mind is that decimal point. All right, and if you remember, when we go to the right of the decimal point, these are our decimals and our fractions. All right, and you also need to know that numbers get smaller. They decrease in their value as you go further to the right of the decimal place. All right, and then on the flip side of that, that marker's a little dry. Let's try another one. All right, and then to the flip of that, oh, much better. The left of the decimal place, those are our whole numbers. All right, and those whole numbers, that also means that numbers are increasing. So as you go further to the left of the decimal place, your numbers are increasing. So keep that in mind, okay? So when it's asking you that question, if it has a place value here and it says the number to the left in comparison, you should be saying that that number to the left is bigger. If it's asking you about the number to its right, you should be saying that the number to the right of that is smaller. Even if you're talking about two whole numbers, 10 would be bigger than a 9. So the further you go into whole numbers, they increase. So even in comparing two whole numbers or two decimal place values. All right, so keep that in mind. All right, so since that's staying up on the board, let's give it a little box. All right, so now let's move on to a decimal place example. We have 0.944. Okay? So, I have two 4s. I have a 4 in the hundredths place. And I also have a 4 in the thousandths place. Ooh, sorry. My nose itches, excuse me. All right. So now we need to compare the two. So how do I put 400ths into number form? I would multiply 4 times 1/100th, which would give me 4/100. If you remember, when we multiply whole numbers by fractions, you can just put that imaginary, there we go, 1 underneath there. And 4 times 1 is 4. 1 times 100 is 100. All right, so we have 400ths. And then remember, when you're multiplying fractions, now that you know it's decimal, all right, equivalency, you can use the decimal. So in reference to our 4,000s, we could write that 4 times 1,000th. All right, and that would give us 4,000. So those are the two ways to multiply, whether you're using the decimal form or whether you're using the fractional form, still coming out, all right, with the same type of answer. Right here, they're not equivalent because we're talking hundreds and thousands. But if I was multiplying here by hundreds, then my 1 would be here and my 4 would be there, therefore making them equivalent. But I just wanted to show them to you in both ways just as a reminder. Excuse me, my nose is just so itchy today. All right, so now we need to look at what is the difference, or in other words, how do I get from 400ths to 4,000ths? All right, so what's the difference between 400ths and 4,000ths? Take a look. Do you see that the difference between their denominators, because their numerators are the same, the difference between their denominators, their denominators is this has 2 0 bags, this has 3 0 bags. This guy has more baggage over here. This has 1 extra 0. So what do we call a 1 with 1 0 bag worth of baggage on it? We call it the number 10. So you could say 4 100ths is 10 times more. And the inverse of that is that 4 1,000ths is 1/10 less. All right? Because remember, the smaller the denominator, the bigger the fraction. It means you're splitting it up in smaller pieces. Okay? So now let's put them together. And let's take a look at a number that has both whole numbers and it's got some things on the right of its decimal place. Okay? And we're going to keep our notes up there. So our helpful hints throughout our learning. All right. So now you're going to write this number. 3,710 354 thousandths. Okay? And we are going to be comparing our threes. Okay? So I have a 3 in the thousands place. All right, my ending right here is letting me know that I am to the left of the decimal. And then I have a 3 in the tenths place. My ending right here letting me know that I am to the right of the decimal place. Okay? So let's compare the two of these. Well, we got to get that in number form. So 3,000ths, in order to get that in number form, I would take my 3. I need to multiply it by a 1 that has 3 0 bags worth of baggage. And that will give me my 3,000. All right. There's that power of 10 again. All right. It's a 1 with 3 zeros. Or when it's the power of 10, you're really looking at that. So it's a 10 with 2 0 attached to it. Okay. So just to help you see where we're going next week, you know, Mrs. Edwards always loves to show you where we're going. This, if I was doing exponents, would be 10 to the second. A 10 with 2 extra zeros. Okay? But I'm going to take that away for now. That was just a little preview into next week. All right. So back to what we were talking about. 3 times 1,000 equals 3,000. Now, how do I get these tenths? 3 times 1/10 gives me 3 tenths. All right. Well, that's a big difference, isn't it? Right? Tenths, I'm over here in decimal land, and here I'm very deep into whole number land. I'm in the thousands place. which is the fourth place value from to the left of the decimal point. So I'm kind of deep in there. So now I need to figure out, using my understanding of power of 10, how do I get from tenths, 0.1, how do I get from there all the way to thousandths? How does that happen? What do we do? All right, so this is how you need to look at it. It's the same thing here as the previous problem. If you're looking at a 10 and a 100, a 10 and 1,000, what are the difference in zeros? This guy has 1 0. This guy has 3 zeros. So those would cancel each other out. So that means I'm left with a 1 with 2 0 bags of baggage, which we know to be the number 100. Okay? So what that means is that 3 thousandths is 100 times more, and that 3 tenths is 100th times less. All right? So that is how you need to look at comparing place value in reference to understanding power of 10, and if something is 10 times or 100 times, or how many times less or more is it if the number is in a different place value when we are comparing them. Okay? And like I said, this is also the same Sorry, I'm on limited space, so if you needed that, just rewind the video and you can get that. But this is the same as if you're looking at 3,341. Okay? If your question says, how is the 3 in the hundreds place different than the 3 to its left? One thing you're going to say is it's increasing, right? Because as we go further left, they are increasing. Another thing you're going to say is that, well, this is in the hundreds place. This is in the thousands place. Difference between 1,000 and 100 is 1 0 bag of baggage. So this is 10 times more or 10 times greater than the 3. Or the 3 in the hundreds place is 1/10 or 10 times less than the 3 to its left. Okay? So now what you are going to do is I'm going to put 6 problems up here, and those you are going to work on your own, and they will be due this Friday, May 1st. Okay? So the first problem, you're going to look at 6,476, and you're comparing your 6. The second problem is 300,300, and you're comparing your 3's. Your third problem is 1,756,401, and you are going to compare your 1's. Okay? Then you got a couple decimal ones. So your fourth problem is 0.898. And you know what? I'm actually going to switch that so the decimal places don't get confusing. Number 5 is 0.2114. And 6 is a combination. And that's 50.375 thousandths. All right. Oh, sorry. For number 4, 0.898, you are comparing your 8s. For 5, 0.2114, comparing the 1s. And 6, 50.375, you're comparing your 5s. And you're going to tell me how do the place values compare? All right, how do they compare? All right, so when you're looking right here, how does this 6 compare to this 6? Just like we've been working on throughout the video, you need to look at that. What place value is that in? What place value is this in? And how much greater is this 6 than that? And how much less than is that than that? So what I should see for each one is how much greater one is and how much less than the other one is. All right? Or if you need more direction, more focus, be specific and tell me. How does the digit on the left compare to the digit on the right? All right, so you could get even more specific and more focused with it. How does the digit to the left compare to the digit on the right? All right, if you have any questions, you can give me a call. And as always, I love you guys. I hope you are continuing to stay safe and stay healthy throughout all of this. Please know that even though I do not get to see you every day, you are still in my hearts and in my minds every single day. I love you and I miss all of you. And until next time. Mwah.